Okay, so the quotient rule. We just did the product rule. The product rule is how we take the derivative of the product of two functions. Now we want to take the derivative of the quotient of two functions, because a lot of times we don't just have one function, we have multiple functions involved. So how do we address that? First of all, you take the derivative of f divided by g is given by the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. That is a lot to remember. So I put in a memory device. I put in also an easier way to think of it or write it using U and V, whichever way you want to organize. For some reason, if I use this memory device on the right hand side, if you could think of like the seven dwarves from Snow White, hi ho, it's off to work we go, da 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 da, that song, right? For some reason, when I do this, people tend to remember it. So high means the one on top, the upper function, and ho is for low, the lower function. So it goes ho de high minus high de ho, draw the line and square below. So it's ho de high minus high de ho, draw the line and square below. I wrote it out in words, what I'm saying just now, down here at the bottom, because most of the time that's what's going to go on in your brain as you're doing it. But before we can use this theorem or this rule, we have to prove it. So I have dx of f of x over g of x. We're going to use the limit definition of that. So the limit of, as you can use delta x or h. I'm going to use delta x. As delta x approaches 0, of f of x plus delta x over g of x plus delta x minus f of x over g of x all over delta x. And the first step is really just to, this is a complex rational expression inside the limit, so let's rewrite that by multiplying by g of x times g of x plus delta x, just to get rid of the smaller fractions inside the bigger fraction, get rid of the smaller fractions, so it's a little bit simpler to deal with. And then we're going to rewrite that, and after that, we're going to do something similar. The way we proved the product rule, we're going to do something similar to that. So first we end up with g of x times f of x plus delta x when I distribute in the numerator, minus f of x times g of x plus delta x all over delta x times g of x times g of x plus delta x. So after we've done all of this, first of all, I can tell that I'm taking, if I look, I'm cheating a little bit, I know. This is the result I want. I want to have g of x, I'm looking all the way up at the top of the screen. G of x times f prime of x. So my goal is essentially to have f prime of x in the front there. So that's a clue to what missing terms I'm actually going to put in, because I want to create essentially f prime of x in the front. So I'm going to do the limit of delta x approaches 0 of, and then here I have g of x times f of x plus delta x. Then I'm going to either add and subtract the same two terms in the middle here. So I have minus f of x times g of x plus delta x here on the end over delta x times g of x times g of x plus delta x, like that. So if I look again, oh look, I'm going back up here at the top and looking, I needed the f prime of x. So to get the f prime of x, I need f of x plus delta x minus f of x. So that's what I'm going to concentrate on, but I need to be able to factor out a g of x then. So that means I'm going to do minus g of x times f of x, because when I group those two terms together here, these first two terms together right here, when I factor out the g of x, I'm left with f of x plus delta x minus f of x, which is how I'm going to get the f prime of x. So if I add it, or if I subtract it, excuse me, I also have to add it. So g of x and f of x. And that whole explanation I just went through, don't worry, you don't have to do this on your own. It's not an expectation that you know how to prove these on your own, like that. All right, so now we're ready to separate. So I'm going to write the limit as delta x approaches 0 of, factor out in the yellow grouping the g of x, and that's going to leave me with an f of x plus delta x minus f of x times, and I'm going to rearrange it a little bit, and don't I know there's a g of x over a g of x. Don't reduce those. It's not going to be helpful for us. Of f of x times, g of x times g of x plus delta x, and then times the delta x. I'm just rearranging here on the end. And then we have plus the limit of delta x approaching 0 of, now if I look at the numerator, the green grouping, if I take out an f of x, I would end up with g of x minus g of x plus delta x. It is almost the definition of g prime of x, except that I need it switched. I need the x plus delta x in the front. So instead, I'm going to actually factor out the negative of f of x instead. And that's going to give me a g of x plus delta x minus g of x. And then I'm going to write it like I did before. And it's just to save space, really. So I don't have to write a whole other line out here. X plus delta x times delta x. Now the parts that I'm highlighting, I'll start with blue here, if it'll let me. This part here with this and the limit. That part itself is the definition for f prime of x. So essentially, that part is f prime of x. I'm going to highlight that in blue, right? And the same for the second one. I have a similar situation. Let's highlight that in pink. This part here with this, given this limit, is going to give me g prime of x. So g prime of x, that's the definition, based on the definition of derivatives, right? That's g prime of x, just to let you know. So that is going to, let's simplify that a little bit. I'm going to have the limit of, so let's think about this. The blue part is f prime of x. Okay, f prime of x when I apply the limit. The g of x in the front here is not, in the numerator, is not going to be affected because there's no delta x in it. So that's g of x. In the denominator, I have g of x times, and then applying the limit, the delta x approaches 0 becomes another g of x. For the second one, the second limit, there's a negative. I can take that out. The f of x is not affected by the limit because it's delta x approaching 0, so it's just an f of x, times, in the pink, all of that is the definition of g prime of x, over, in the denominator, I have g of x, times, when I apply the derivative to g of x plus delta x, it's going to be g of x as well. Oh, look, they have a common denominator, so I can write them into one sentence. In the denominator, it's going to be g of x squared. In the numerator, I have g of x times f prime of x minus f of x times g prime of x. And there you have it. We ended up with what we wanted to prove in the end.